check with Steve, okay? I will get started. Okay, Steve coming. Hi, Steve, how are you?
I'm good.
Okay, and Sarah is taking the user code competition this time, okay? Anyway, so let's get started, okay? Last time we get started for this C double plus data structure and algorithm, and we covered how the hash function work, okay? We actually directly jump to the searching and hashing, okay? Because previous one we already covered. And then we discussed the use of the hash function and how hash function being built, okay? So basically, if you use the linear search, it is an order of n algorithm. Binary search is order of log an algorithm. If we use a hash function or map, this one is order of one. So this one is welcome, okay, using hash function and the map. So hash function and map, it is one same thing, okay, one same thing. That means you have a property, you have a key and a value. Sometimes it's key called property, okay, and the value. So basically, based on the key, this key can be a number or can be a string, whatever data field. So these two fields can of different value. So sometimes you use a map of integer. So it's an integer to integer map. Okay, but anyway, this key value can also be a string. It's possible to be a string, and you can use a string to map to a certain value. Okay, and then you will try to complete with the order of one. So you use a hash function. So basically, any of the key you have will be used to calculate using the hash function to hash to a certain location in the memory. Okay, and then you store your value. That's how you achieve order of one because the hash function is only a arithmetic calculation. It will be a fixed time operation. So it's an order of one operation. You will find a location for the value, okay? But because you are using a hash function, so basically some of the entry you have data, some of the entry may have multiple hit. When you have a multiple hit, then you need to use a collision method to solve the collision. So solve collision avoidance can be using a linked list over here. That's one way. But linked list will take more time. Or you do rehashing to rehash to a different location. And rehash function, last time we basically show you the basic linear probing, quadratic probing. Okay, we did not do the coding because it's wasting time. It's so most of them are very easy function. Okay, and we do not actually spend time. So right here, what we would do is we will look at the coding for a hash function, okay, and then we will go into looking into the use of map and hash function to in our competition. Okay, that's the purpose. Hi, Helen, how are you? Okay, because of that, let's actually look at the hash function. Let's look at the hash function, hash class. Okay, let me bring up the file I already have. I don't want to rewrite it because it's taking a long time. Our purpose is not to just looking at the code, okay? So let's look at this one. Okay, so right here, I do have a hash function. This one, I have an array. okay? And then there is a hash, this one. This one coming from, I believe it's coming from the utility. This one, let's see. Okay, so this hash is a standard hash function that you can use, okay? And then these are data types. So they are standard hash function you can use calling from functional. You have a hash function that you can put the hash type and then it can calculate the hash function for you. Okay, so this one you have a string, and then based on this string, one by one, you put alpha in there, it hashes to a new, it will hash to a certain number. That's the size t is actually an integer. Okay, so basically you hash this to an integer, hash this to an integer, hash this to the integer, hash this to the integer. So basically, I think it's from maybe from this utility library. It gives you the hash function, okay? And then you calculate a simple hash function for you. Let's see. This one, if we run it, okay, it will show you how this alpha, beta, gamma being hashed to a different number. Is that okay so far?
Yeah.
So this one tell you if you need a hash function, okay? In the past we teach you how to use map, okay? But this one is teaching you like how to use a standard hash function without writing your own hash function, okay? And you can use like last time we show you actually you have a alpha, then you can do character A plus character L plus character P plus character H, okay, plus character A, and you design your own hash function by this is sum of the character. So sum of the character 10 modular by 47. And you can finish. But this one is actually a brute force solution, just showing some basic easy hashing from 1 to 46. Okay, this hashing is like that because you take modular from 0 to 46. This is the hashing to 46. But that's not what a professional one is. A professional one should hash to a large number. So that will spread out the number. Okay, so here one more question. If you list the hash number is too big, say I only have 4 mega of the memory. Okay, I don't have this, then what can I do? Then you get this number, you can 10 modular by 4 mega, and you will go to 0 to 4 mega minus 1 range. So you will still hash to a fixed location. Okay, so this is a hash function from standard. It will give you a large number, but that's not large number. Don't get afraid. It give you enough number of the digit. Then you can do modular to cut it down to a smaller memory size that you have. Okay, is that okay so far? So this is the first one, the hash function. Okay. Any questions so far?
No.
No. Next one, let's see. This one is this one is a hash function. Let's see hash set. Let's see. No. Let's see the hash set without probing first. So here we do have hash set without probing. Right here we do have a function. This one is called hash table probing. Okay. Let me do this, okay? After we finish that, let me actually send you those code, okay? So you can take a look on it instead of just watching, okay? Let's actually look at it. So this one from data structure right here. I have CPP and it's from Union 3. Let me see. No, I'm sorry. Not usually. It's from practice, and it's from hash function. And let me give you the hash number one, and then let me give you the hash number two. These two functions we just see. Okay. Okay. Let me make sure I send you right away so we can check the different code. So this time, let's look at this one. This one actually is doing hash table probing. Okay, give you the idea of how probing has been done. Okay, so there's that H file that will do the probing for you. Okay, anyway, and then as you said, probing one and probing two are using the hash set probing. So HTTP probing.h, this one is a definition file. So let me send you this definition file first. It's on one level up, hash set. And then this one is a hash set. Let me see. CPP. No, I'm sorry. One more time, let me check which file it is. Okay, sorry. This is actually in the with probing, without probing. Okay, I'm sorry. So it actually is from the without probing, not from the probing one, without probing. So without probing is that you calculate and it's not probing. So this one is the H file, give it to you. Okay, let's look at this H file, and then it is used by the .cpp file, two of them, first use and the second use. Okay, let's do these two. Okay, so basically, let's actually look at the code. So this one, you do have a hash table. So this hash table, we do have this one. It's actually a conversion of a number. This one is to convert number to string. So this one is a converter to string. Okay, this one's an easy converter to string function that we talked about it before. Now this one is called probing headset. Probing headset. So here you have a key and value. Okay. So you have a key and value. So here you have a loading factor or maximum loading factor of 0.5. Loading factor is that you have multiple entry. Maximum, you only allow the loading factor up to half of the table can be used. You don't want to jam it, okay? If it's close to 1, then the efficiency will drop because of the too much collision. So loading factor is one of the things that you need to watch for the hash set, okay? So each one of them, you have a bucket. A bucket is like this. You have bucket, you have key, and you have a value. And the bucket is like they have a linked list or something, okay? So it's a structure. So this one, it has a constructor and key and value pair. And then when you return, it return the key and value, okay, for the toString function. So bucket is actually a pair, okay? It's actually a pair. Okay, so here this one is inner structure. So it's a structure inside a class, okay? So it's the inner structure. Now let's look at it. So you have vector of the bucket. So this hash table really is a hash of a vector of bucket. So bucket is a pair. So you have a key value pair and then key listing. Okay. Of course, you use map, that's also fine. You use something else also fine. But right here, we're using bucket. Okay, bucket is actually similar to a map. And then there is an insert function. It uses underline, means that this one is a private function, or this one is a internal function, hidden function you don't want people to see. So this one show you how the insertion being done. Okay, this one show you how the insertion being done. This one, this function insert is underlined and it's put into the private section. So public section is right here. So this insert function is a private function. Outside, you cannot see this function, okay? Usually when you see an underline or underline, it normally is a private function or hidden function, okay? That's the naming convention. So here it show you like, okay, they try to probe it while you find an empty bucket. When you find an empty bucket, then you insert a key and value over the bucket locations, okay? So this one is a simple probing function, okay? Okay, so you create number of bucket and then you have the loading factor. Loading factor is by calculation. So your number size of the current size divided by total size, you get a loading factor. Okay, and then you actually there's an insert function. This insert function there is no underline, so this one is an external insert function. So external insert function is that you try to look at the loading factor. If the loading factor greater than 0.5, what will happen is like you do rehash. Rehash means that original your table is one size. Now you duplicate to double the size. So you do times 2. So rehash function is building your original hash function by double the size. So double the size means that you have bucket size double. So originally, let's assume that you hash to this and this. Now you double the size, so you do rehashing. Then rehashing means hash to this and this. And you have originally you have 2 empty size. Now it become a yellow one. Originally you have 2 empty size. Now you rehash to have 4 empty size. I'm sorry, 6 empty size because you double it. Does that make sense? So your loading factor from 0.5 increase to 0.25, drop down to 0.25 because you double the bucket size when you double it. Okay, so this is when your loading factor greater than the maximum load factor. So maximum load factor is determined as a constant that you can change right here. And once you actually over, then you do rehash. So rehash is right here. It actually create a new bucket, a new vector of bucket of the new size. And then you insert the old one. So you use the internal insert function to insert the original data one by one to the new bucket. So that's originally you have 4 entry, okay? And your loading vector reach 50%. So you have this one and this one that have value. Now you double the size to red one. So you have 8 of them now. So this rehash function is to double it. And then these 2 existing data, you rehash to a new location. Okay, this is how this rehash works. Does that make sense? Hello?
Yeah.
So here, I don't rewrite the code. The code is not that hard, but it takes time. It spend me 2 days to finish this one, making sure there's no error. So this data structure, of course, we basically talk about topic more, okay? Because this is more advanced coding course. We don't go into the detailed coding. That would waste time. So our lecture 1, we are on competitive programming. So you look at the number I use right here, we are talking about number 2. This one is a hashing function. Okay, so I don't know how many topics I can cover, but each time I increase the topic number, okay? This year, I try not to use chapter 1, 2, 3, 4. The chapter is not a good combination, good way to teach it for data structure. So here we go by the topic, okay? So this week, we continue to talk for the hash function. And then rehash function is when you have original hash table, but it's actually reach the upper bound for the loading factor, then we do rehash. So this one don't have underline because this one is a public function. Public function, you want people to use it. When will you do rehash? You do rehash when you do insert, that your loading factor is greater to the maximum loading factor allowed, then you will do rehash. And your loading factor is calculated by your current bucket size, that's as a base, and then your occupies the data size, number of bucket used over the total bucket size. If it's greater than 0.5, then we will do rehashing. Rehashing means that double your table, okay? So this one is rehashing. Content is to see if the value is inside it or not. You do hash the value, do hash function. You see, you create a big number and you multiply by bucket size because this hash function could be a huge value. Okay. And you actually need to multiply by the bucket size. So it will be just as many as the bucket size. And then you use that hash number to see if the data is there. Okay, if it is there, then you actually return is true. Okay, and then if not, you increase the bucket index by 1. So this one's linear probing. Current one, I don't see it. I see next one. I don't see it. I see next one. If actually you keep doing that until you hit a empty one, that means you don't find it. What does this mean? Okay, let me talk about it one more time. So when you do hashing, you hash to a certain location, then you put your value there when you insert. Okay, when you insert. So that's so this key is 2, your data is 1, you hash to here. Now, if you do have a 3, but you also hash to this same location, okay, then what will happen is that you will go to the next one and put a value here if this one's empty. If not empty, I'm going to go for the next one. Okay, until it's hit the empty one and I'll put the data there. So this kind of the method is called linear probing. So linear probing is that when you have a collision, you two data hash to the same location, then you look for the next one, then you look for the next one, okay? And then if there is an empty one, that can only means that the data is not there. It's not there. Okay. So when you do insert, if data is not there, you insert there. If you hash and the data actually already been there, then you don't insert it. Okay. So this one is the content function. So you keep probing, and then if there's an empty one, that means that you are empty. So next one is get. You get a key value, and you do get a key value, and then you hash to the hash index. And starting from a hash index, you kind of look at the value. Okay. But if the value is not what you want, not a key, the key is not a key, you look for the next one, look for the next one, look for until you hit an empty one. That means the key doesn't have the value, then you will go out. You throw exception. Okay. Otherwise, you will return the bucket's value for you. This one's a get function. Okay. Any questions so far? Hello? Any questions so far? For this get function? Helen, are you okay so far?
Yeah.
How about Steve? Are you okay so far? Hello? So why we did not use the hash function here? Okay, last year I actually Helen, no, last year I teach this hash function, but this hash function is too easy for this text. This textbook tend to be too easy, okay? we use it as a textbook just because it provides us the right topic and basic discussions, okay? But as for the coding, it's actually too easy, so I give up. I give up. Okay, so this one show you how a hash table class can be implemented. Okay, including the bucket, including the vector of buckets. Okay, and then the internal insert function and constructor loading vector calculation, external insert function, and also rehash function, contain function, get function. Okay, these are the basic one. This print and show are easy. Okay, this not important function. So this teach you how to implement a hash function. Okay, and when we use it, you create a probing hash table. So this probing is linear probing. Okay. Last time we talked about it's possibly linear probing using linear jump or jump by one. Okay, that's a linear probing. You can also do quadratic probing, like actually use a quadratic function to jump to a different location. Okay, so here this one's a linear probing. Linear probing's advantage is that the algorithm is easy, but the disadvantage is that they may be more collision because you hash to a certain location. You look for the next one right away. That may be a collision again. You hash to the next one. Okay. Quadratic is better, you jump further away, but quadratic has a drawback that the quadratic calculation take longer time. Okay, take longer time. So basically right here, you do hash table, and then you kind of insert I and I square. So this hash table is I and I square. Okay, and then you check if you contain 3, contain 15, and then you try to get 15. Okay. So these are basically, this is similar to the use of hash function, but right here, I just use it for the discussion of the hash table, okay? So it can be wrong and okay, so there is some of the hashing function you don't find, so you got an exception, okay? But other things that they do get some data, okay? Anyway, that's, I think right, this year get some of them actually you get an exception. So number 2 is another one, okay? Another one for the probing function. But this is a probing function based on the internal hash function that are written, okay? Now, so this portion is okay. We are kind of just want you to look at a implementation for hash function and also how to use the hash function, okay? Now, let's go back to the different topic, okay? So what I want to say is, okay, this one is to teach you how the hash function being implemented, okay, being implemented. But in the competition, say you go for the user code competition, you don't have time to write your own hash function. Okay, that's actually take too much time. Okay, that take too much time for you to write it. So most of the time you are using map or multi-map. Okay, map is a map of the key and value. And then you have the key of 1, you hash to with a value of 2, key of 2, value of 3. Okay, that actually is called map. Multi-map allowing key of 1 and then value 2. And then later, if you have a key of 1, value of 3, it is allowed. This is multi-map. Simple map, single map, or original map do not allow a multiple key. Is that okay?
Okay.
Okay, that's the main difference. And then this one is that maps key issue is you have key and the value. Okay, and set, you only have a key. Okay, and set, I say that is a special case for map, so we don't discuss it here. Now, When do you want to use map? That's the question. When you do competition. So Helen, when do you want to use map? Hi, Helen, do you hear me? Hello? Hi, Helen, do you hear me? How about Sherry? When do you want to use map?
Um, mm,
When do you want to use a key and value pair uh, in the map?
like, sorry, like, um, when you have like a series of like items you want to store,
You have series of items you want to store. Why don't you just use array?
because like array it's like too short. Like, it doesn't.
No, array is not too
Yes.
short. Array actually has same size or even smaller than map. So Steve, when do you want to use map?
Maybe like a histogram,
Hmm?
really like a histogram.
Histogram, you use array. Yeah, sometimes you use a histogram to count the number of character, yes, or number of word, yes. But you can still use array or array list to implement it. Okay, how about Helen? When do you want to use map? Hello, hi Helen, hear me? Okay, anyway. You want to use map still because it's order of one algorithm. Okay. So let's assume that you have array of, let's assume you have array of array A that has index of 0, 1, 2, 3. Okay. And the data is 2, 4, 6, 8. Let's assume that. Okay. So no more array. If you want to see 6, you want to see if the 6 is in array or not, you do linear search. That's an order of n. And you want to index, then you do need to use the order of n. Then if you have binary search, you need to use the order log n. Okay. So if you want to really know about the index right here, you want to get which index has the 6. Then, and in the faster computation, then you can build, okay, your original data is A, you do have a 0, 1, 2, 3, this is index. The value is 2, 4, 6, 8. Now, I put this whole thing into a map. So this map has a key and value. So the key has 2, then the value has 0. That's the index you have. Key has 4, value has 1. Key has 6, value has 2. Key has 8, value has 3. So now if I say where is 6 in the original array, this one you use an order of 1, you can automatically return 2. And then you use that to get the array index. So map sometimes can use together with array. Your original array is like this, and then your your value, your map is like this. So you X like key of 6, get 6, you will get a value of 2. That's the index that you have. So it's an order of 1 algorithm. Is that okay? Is that okay? This is the use of combined array and map. Okay, again, this array and map, because we are talking about this combination, so you know it. But when will we use this one? So when are we going to use a map and array together? In what situation we would do programming and we need this? Sherry, do you know?
No.
Steve, do you know?
I'm not sure.
This is called reverse array. Your normal array is you get index, you get the data. You give index, you get the data. Now, you give the data, you get the index. You give the index, you give the data, you get the index. So this is reverse array. Okay, so when do we want to have a reverse array? Let's look at this one. So let's assume that we have a shuffling network. Okay, so let's assume we do basically we have 0, 1, 2, 3, and this one is 0, 1, 2, 3. So 0 location go to 1, 1 go to 2, 2 go to 3, 3 go to 1. Okay, so this is one shuffling. So after that, you actually do another shuffling. Your 0 go to 1, 1 go to 2, 2 go to 3, 3 go to 0. One more shuffling. One more shuffling, your 0 go to 1, 1 go to 2, 2 go to 3, 3 go back to 1, go back to 0. So if you have this shuffling, say, let's see. If you are originally 1, after 3 shuffle, you will go to 2, and then 2 to 3, and then 3 back to 0. So after 3 shuffling, your original 1 go to 3. Okay. And then if you go starting from 2, you go to 3, 3 go to 0, 0 go to 1, 3 go to 1. Okay, so basically this one is a forward, no problem. Okay, no problem. You use an array and see the destination array, go to destination array, go to destination. Now, if I have a eventually go to this location, and I want to know where it gets started from. After 3 shuffle, I know that I'm at 3, but I want to go back to, I want to know where I get started from. In this case, you do reverse array. And you can know that it came from 0. Does that make sense? This
Okay.
is called a shuffling network. Okay. Okay, this actually is an actual problem in user code. Okay, I'm talking about actual problem in user code. They do have such a problem before. Okay, so in this case, you do need to do reverse array very often, okay? So let's look at this one, reverse array. Okay, let's look at this one called reverse array. We want to use a reverse array, okay? So reverse array, since it's using map, so we are going to use IO stream. And then we also would include map. Vector, okay. And we will also, let's do using name space std integer man boy. Okay, return 0. Now we want to build a reverse. So let's get the data. Okay, let's get the data array. Let's assume that the data array is pretty simple. Okay. And then this one, we have the data of 10, 20, 30, 40. Okay, so this is my original data. Now I want to have a hash shuffling array. Okay, so shuffling array, shuffle. So this shuffling is a mapping relationship. So it's also doing for. Okay. So, okay, so your shuffle of the index 0 will go to 1. 1 will go to 2. 2 will go to 3. 3 will go to 0. Okay, so that's how you shuffle. So this one we put 1, 2, 3, 0. Okay, this is the shuffling. So your original data is 10, 20, 30, 40. Okay. Now let's do after. So this original data is like that. Okay. Let's do after 3 shuffle. Let's see what the data should be. Okay. So let's see. Let's actually for integer I equal 0, I less than 4, I increase. So this one will shuffle for 4 times. Will shuffle for 4 times. So here we'll create an integer B array of 4 elements. Okay, we'll create 4 element B array. And then let's see. Let's actually create on outside. Now don't create in the inside of the folder. Put it over here. Okay. Okay, for 4 number, it will be the shuffling result. So we are going to look at the shuffling result. So let's see. Actually, we will do. We will look at it. So let's assume that we will go for 4 of the data. Okay. So the first one is actually A0. So A0, you will go to shuffle of the 0. So basically, B's which index? B's shuffle of the i's value. So your I is 0 and you shuffle to 1. 1 is your B location. So B of 1 get your value of A's value. That's it. This one will do shuffling. Okay, let's look at it one more time. Your original data is right here. You have A array. That's 10, 20, 30, 40. You want to shuffle to B array. So which B array you will go to? Okay, you will actually say your A of 0, this zero value will go to shuffle 1. So you go to 1, you go to B1. So B1's value got assigned with A0. Okay, one more time. So this 20 is I equals 1. So your I equals 1, your shuffle of 1 is actually 2. Your B2 be assigned with A1. So your B2 will be assigned with A1's value. So by doing this, you will finish a single shuffle. Okay, so this one you will shuffle for the 4 data. Okay, so this one A the length, A the size. I'm sorry, A don't have size. A is an array. No, A don't have size. That's useful. Okay, so this one actually is shuffled for all of the 4 data. And now you want to shuffle for 4 times. So you will have integer j equal 0, j less than 4, j increase. This one you do shuffle for 4 times. And the internal I, it is shuffle each number. Okay? Then after that, you want to do print vector. You want to see your print vector. Okay? Print which vector? Print your B vector. Okay, so that's print vector name. So okay, so each time we print the vector after shuffling, okay, let's actually print the original A first. So let's do print vector of the A. Okay. So right here, this one, because I print B, but after print B, I need to assign everything in B back to A. So like my A got updated, then it can shuffle for a second time, so forth. Okay, so this one is shuffle network. So you original from 10, 20, 30, 40 is shuffle to the last value. Okay. Okay, so this one tell you actually using the shuffling function, forward shuffling function, using array. Okay, using array to do shuffle. Now let's do backward recovery. Okay, backward recovering. Okay, if we want to recover the data using the reverse shuffling. Okay, now we want to do backward to recover data from the shuffling result. Okay, so we need to have a reverse array. But at this moment, we only have this shuffle. So we need to create a map. Okay. So right here, we need to create a map to do shuffling back. So here, we do have a map of integer, reverse array. Let's call it reverse array, okay? Okay. Then we would like to do for integer I equals 0, I less than 4, I increase. Okay, so here we are going to put the data from the shuffle to the map. Okay, so let's do C double plus map insert. Okay. This one is actually called, okay, let's look at the map function. So this map function, we would like to actually see. Okay, insert element is it's called insert. Okay, I'm sorry. Now this one. Okay, so it will insert your position, insert your first. Let's see, insert. Your map of these, you do have map of these. Then you want to insert your map is my map. When you insert, you will create a pair of the value and put the two value there. Okay. That's one way you can do insertion. Second one is you actually have okay, this is one way that you do insert. Okay, so basically that's use this one. Okay, so right here, let's do this one. I'm sorry. So this one, it is your R array that insert this one. So here you will insert your key, your value, your location is your shuffle I. Okay, your shuffle in reverse array. So use your shuffle. Your shuffle I and I. Okay, your shuffle I and I. So this will create a reverse array relationship. Okay, so originally you have 0, 1, 2, 3. Your shuffle array go to 0 go to 1. So 1, 2, 2, 3, and then go back to 0. It's like this. Okay, it's actually like this. Okay, so here it should store 1 versus 0. This one is your shuffle location is actually coming from 0. So it also tell you it's backward going back from here to here. Okay. So you do create such this thing. Okay. Okay. Ahead and you have something to do, you just go, okay, if you need time. Anyway, this one is a reverse array got inserted with this. Okay, now we are trying to recover it. Okay, so right now your data after 4 shuffle, you go to back to here. Okay, so 4 shuffle, you go back to the original. Okay, you actually go back to the original. Now let's do reverse shuffling. Okay. Let's assume that is a 4. We'll backward go back for 4 times to go back to the original. Okay. So that's actually try to do the reverse shuffling right here. Okay, you go back 4 times again. Okay. So now your A is your original data. So now your A is right here. Your A is 0, 1, 2, 3. This one you go back to your B array is right here. You go back to here. Okay, you are recovering the data from backward mapping. Okay, so you would like to get the location and find your B location. Okay, so basically you should use a find function to find where the number is. Okay. So this one, you should go use the find function. Let's go back. So you will use the map and you will use element access. Let's see it. Okay, so you use the add function, okay, you can get a value. Okay, so basically, this one is R array that at your I, okay. So this I you had 0, 1, 2, 3. This one will go back to 0 to reverse. Okay, the rest of them is the same, no change by doing that. That's good enough. Okay, this one is good enough. So here, before we do this, right here, let's do C out handle twice. Okay. And then this one we do reverse shuffling for you. Okay, that's wrong. Okay, so this one, your 40 go back to here, this one go back to here, this one go back to here, this one go to here. So this is reverse shuffling, go 4 times, you go back to the original. So here is a reverse shuffling, it's going this way, this way, this one the forward shuffling. This one do backward shuffling, going this way, this way, this way. Any questions so far? Okay, this show you how to use a reverse index. This is forward shuffling and backward shuffling. Okay, right now I'm using 0, 1, 1, 2, 3, 0. It's easy. You actually can use a very more difficult shuffling. You can go this, 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 this. Okay, the shuffling network can be very different. Okay, so let's try this one though. So right here, let me comment it out. Okay, this is original setting. Let me copy one more time and try new shuffling function. So it actually 0 go to 2, 1 go to 0, and then 2 go to 3, 3 go to 1. Okay, this is more complicated shuffling. But the function should work again to recover the shuffling, okay? Okay, let's see. 0 go to 2, 2 go to 1, 3 go to 2 go to 3, 3 go to 2. Okay, but after foreshadowing, go to the original. After foreshadowing, you go back to original. Is that okay?
Yeah.
Okay, so anyway, I just want to show you the power of using map as a reverse array. Okay. And the shuffling function we talk about so far, is using the hash function. And hash function, hash table map. That's the first part when we talk about data structure. So here, okay. Here, this one is an example. We go talk about the data structure first. When you study the data structure, you talk about data structure first. Your data structure is a key value pair. You kind of a key value, key value, key value, key value. That's your data structure, right? And then your algorithm, when you try to solve problem, that's the algorithm part. Then you use the data structure to look at how shuffling being done. So the algorithm deal with the shuffling and reverse shuffling. Reverse shuffling going back to the original location. So basically, we say the problem solving with data structure and algorithm is that you need to know both about the data structure and algorithm. The data structure, we teach you how the class is being built, right? We teach you how the class is being built. While the algorithm is we tell you how this data structure, when you use, can be used to solve a problem. So here we use the shuffling problem as an example that teach you how to do reverse array to solve a problem when you have tried shuffle several times and you want to go back to your original setting based on looking at the value you got from the end result, and you can quickly recover it in order of one time for the shuffling. Is that okay so far? This is the purpose of study of data structure and algorithm. So every week we will focus on a topic. So this current week is hash function. Okay, and we look at the data structure, what data structure we will use. And then what algorithm or problem that we can use to solve. Okay, and if possible, we try to look at some user code example, so help you to make sure that data structure, basic algorithm use, and real world application, you can all look at it. Okay, does that make sense? Okay, it's actually ideally we want to teach in that way, but we need to go through several different topics. Each week we will have one topic. Okay, so this week we starting with this hash function. This is the way we use a C++ to teach data structure and algorithm. Okay. Any questions so far? Let's go back to the hash function to finish it. Okay, right here. So this chapter, it goes through this hash function and hash collision. We talked about it already. Okay. So this part you can study. Okay. Let's see. So this is not a very difficult chapter. Okay. Anyway, this one I'm going to give you this reverse array C++ file. Then today, because this topic is shorter, we are going to look at one user code problem. Okay. Let's look at one user code problem. Okay. Let's see. Let me search for internet if I can look at the shuffling problem. Okay, let's look at this one called ball-wing shuffle. Okay, this is the one I'm talking about. Okay, so let's look at this ball-wing shuffle. So Steve, are you okay so far?
Yeah.
Okay, let's look at this ball-wing shuffle problem. Okay. So this ball-wing shuffle problem is that convince the happy cow get more milk. Farmer John had installed a giant disco ball in his barn and planned to teach his cow to dance. Okay, whatever, this is garbage. Looking at popular cow ball dance, Farmer John decided to teach the cow how to do ball-wing shuffle. Ball-wing shuffle consists of his cow 1 to 10,000, 100,000. Okay, n. Okay, they are n cow. Okay, at least n number can be 1 to 100,000. Okay, line up in the same order is a successible shuffling, each of which potentially reorder the card. So it will reorder the card. Okay, it will potentially reorder the card. To make it easy for his card to locate themselves, farmer jumps mark the location of his card with position 1 to n. Okay, so it's 1 to n. So first card in location 1 and next 2 and then up to n. A shuffle with A1 to AN move one position I to AI in the shuffling. Okay, so every card move to the new location during the shuffle. Unfortunately, all AI are not necessarily distinct. So multiple cards may move to the same location during the shuffling, after which they move together for the remaining shuffling. Parmesan notice that some position lineup contain cards in them, no matter how many shuffles take place. Please help him count out the number of the such positions. So you have first line input of n, that's the number of cards. Okay, so you have 4 cards. And then here it contain integer a1 to an. So you basically you have so this problem when you have a1 to an, you can convert it to array format. So it's a0 to an minus 1. Okay, this one we don't discuss. So this is 3, 2, 1, 3. You can change it back to 2, 1, 0, 1. Okay, that's easier. So now you have 0, 1, 2, 3. This one 0 shuffle to 0 shuffle to what? 0 shuffle to 3. I'm sorry. Let me redraw it. So 0 shuffle to 3, 1 shuffle to 2, 2 shuffle to 1, and then 4 shuffle to 3. Okay. Okay, now this one is a shuffling network, okay? Now the question is that please output a number that always has contained card, no matter how many shuffle take place. So how to solve this problem? Right here you have 0 go to 3. This actually 1 go to 2, 2 go to 1, 3 go to 3. So if you get started from 0, this location 0 will disappear, right? This location 0 will disappear. So then you become 1, 2, 3. So 1 will go to 2, 2 will go to 1, 3 will go to 3. There's no longer 0, right? And then 1 will go to 2, 2 will go to 1, and 3 will go to 3. So 1, 2, 3 will remain, and eventually you will have 3 of them. So this one, how can we, based on this input network, to analyze eventually how many of them will be staying, no matter how many shuffle take place? Because they might be, let's assume that we may have 0, 1, 2, 3, 4, 5, 6, 7. Okay, let's assume that this We don't go to 0, 1, 2, 3, 4, 5, 6, 7. So 0 go to 2, 2 go to 1, 1 go to 2, 3 go to 4, 4 go to 3, 5 go to 6, 6 go to 7, 7 go to 7. Okay, let's assume this is the one new one. So what happened is 0 would disappear, 5 disappear. Okay, so the array that no one go to will disappear for sure, right? For sure, right? And then how can you know that a number go to some location and it will always be there? How can you know that this number will always be there? Okay, there's a question. How can you prove that a number is always be there? Or can you pick something that you will disappear? Okay. One way to do it is that no matter what network you set up, you just keep running for a certain time and making sure that you just check it, which one it exists. But that would take, say, you have order of n and you need to run order of n times, so you will end up with n square algorithm to solve this problem. Or for sure, you should be able to solve the problem using the n square algorithm. But I think that's not the solution. Okay, that's not what you want to do. That actually would take a longer time to figure out. Okay. So one way is that if you some number that you don't have someone going to, okay, then those are out. Those are out. Okay, so 0 go to no one go to 0. No matter 0 go to where, 0 go to 0, that actually is dead. Okay, 0 go to nowhere, then 0 is dead. So what I can see is that actually you do reverse array, and then you see there's a 1, 2, 3, 4, someone going to, the number that someone going to, as long as you are someone going to, then the number, I think it will stay. As long as it show up in the number right here, I think the number would, every stage that will stay. Let's check this hypothesis to see if that's true. So we have 0, 1, 2, 3. We have 0, 1, 2, 3. Let's assume that we actually go 0 to 1, 2 to 1, 1 to 2, 3 to 2. This one no one go to, we delete them. This one no one go to, we delete them. You will go to 1 and 2. 1 and 2, 1 will go to 2, 2 will go to 1. That actually is okay. So this 2 will stay. So then you delete the number that no one go to, then the remaining one, your stay always has someone that go to. Should be fine, right? So if we delete this one, the 0 since no is not going to this 0 is dead. So where 0 go to actually is of no use. This one may be cut. Okay. let's see. So the state that someone go to, as long as you have this listing, and the state that you have someone go to should, I think it will always be existing because there are always someone who will go to here. Okay, so the state that no one will go to, it doesn't exist, so you can kick them out. Okay, and then those states that no one go to, then the link that they have should not be, you do the second time, so you have 1 and 2 left. And the second time, the value still exists. I think that's good enough to determine that this is shuffle should stay or not. Okay, so I think only 2 paths should be enough. Because the first pass, you make sure that you only go to some valid one. Okay, and second pass, if it still be valid, okay, still have some value in there, we can be pretty sure that it should be okay. Okay. So you need to know about which one that has someone coming and which one don't have someone coming. Okay. So you have 4, 3, 2, 1. Okay, let's get started for this one, okay? This one, let's call it boring. Oh, no, we cannot call it in this way. Sorry. Because it's user code format, we have to follow the user code format, okay? It's called shuffle, okay? So the program that's called is shuffle, and there is a shuffle.in and shuffle.out, okay? So let me copy a user code problem, okay? Let me copy from somewhere to get the user code problem. Okay, let me copy this one. Okay, this one is called shuffle. Okay. Let's delete everything here. Okay. So you need to have this. That's okay. So read in the N. Okay. Then let's delete everything else. Okay, and right here we do use a type define, okay, vector of the integer and vi. Okay, we need a vi type. Okay, and we have a vi type when we read in in. Okay, vi. Okay, and then we do actually we do the next line. So we do for integer. We do while loop. Okay, let's see. Let's actually do while loop. We will do in a number of the data. So do for integer I equal 0, I less than n, I increase. Okay. Then we will do vi the push back a number. Okay. So this number we push back would be from bin in to you would have a number called integer x read into x, and then we'll push back the x to the array. Okay. Oh, I'm sorry. This bi should be here. It should declare as bi, and here we will do a array. Okay, shuffling array. So we call vi a. So this one should be a the pushback x. Okay. So we push back different x into there. Okay, that's printing. Okay, that's actually write a print vector. So void print vector via. Okay. Okay, so we basically try to enter all the vector and then just print the vector once. Okay. Okay. Print out the shuffle network. Then I need to have that shuffle the in. It should have 4 and then 3, 2, 1, 3. Okay. Save. Let's go to shuffle the CPP. Let's run it. Okay, so this one print out the shuffling network. Okay. Now next one, we are going to do analysis on this shuffling network. Okay, one thing is for sure is that if on a certain run, your data don't have data go to, then it will not have the number should not let me actually check in this one so later I can. Okay, so let's try to get this one Bowin shuffle use code. Let's go to there. Okay, so I can actually do a submission. Okay, so if there's a nobody go to, I think it will definitely have not going to have be useful. Okay. So here, let's see. We don't want to use a super big array one because it's a huge array. Okay. Okay, let's try to use map then. Okay. Let's try to use map. A multiple entry is allowed. Multiple entry is allowed. So let's try to use a set. Okay, so I'm assuming that actually if there's someone going to, then there will be a value. Okay. So I'm counting the number of the distinct numbers. So let's see. This one we push back it. It's stored into the array. So here, if I don't use an array list, let me use a set of I. Okay, so let's see. If I create let's create a set of integer si. Okay, and then let's do si dot insert x. Let's do cout si size. Okay, let me just use si dot size. Okay, so this one, let's do f out. Okay, so the shuffle will get a 3. Let's see. I don't know. Let me submit, okay? See what happened, okay? I just do the shuffling to see how many data is in used. But let me directly return it. Okay, so basically it's wrong, several of them wrong. So you cannot just count the size of the shuffling that's wrong, okay? Basically that's too simple. Oh, look, okay, let's slightly change our algorithm, okay? We previously we look at the test day, okay? We remove the test day. So just removing the test day is not enough. We should also remove, if there's a stay, it only comes from the test day and nothing else. Then this one should also be this stay should also be taken away, and that one cannot repeat. Okay, so for example, that everyone go to 2 and 3, and this one only coming from 0. That's also need to be taken away. Okay, so we need to modify our algorithm slightly differently. So in order to do that, we will to look at the count in each state after the counting. Okay. We will look at the count in each state after counting. So here we say we have the x is a new state. I forget to -1 because we have 0, 1, 2, 3. We starting from 0. We're not starting from 1. Okay, so we will create another VI. We should create another VI. Okay, here we have VI of the shuffling array. We should have another one called VI after. So VI after, let's create it right here, after here. Okay, so here we have VI after, and it's size of n because we have n numbers. And then we had this one, a pushback of the xi. So okay, so we should increase the number of the dependency for the dependency that actually. So this after is counting the number of a certain location's count. So when we enter a x, then the people the count that go to x will increase as well. Okay, and a remaining using the shuffling locations. Here we use x -1. Okay, we use x -1. We have to use the number consistent with the count order because we have used the -1. So let's do this. Let's use s decrease. I'm sorry, let's actually enter it and then do x decrease and then push in x. and then increase the X location. Let's do this, okay? Let's do this. So this A is recording the shuffling network. After of the X is counting the occurrence of each location, a number of cow in each location. Okay, so we do have the number of cow in each location. So our ANS is the answer we want, is the state that remaining for the number of cows. So initially we will have a number of n, okay. So now we need to figure out what are the no cow states. We need to figure out what states has no cow. So let's create a VI no cow. Okay. Then let's go through everything that actually, let's go to for integer I equal 0, I less than n, I increase. Okay, let's go through every single one. Okay, so if the after of the I actually equal to 0, then this one has no cow. So this one has no cow. We will actually do no cows. So ANS keep track of the total number of the state that has still have cow. And then we pick out all of the cow that actually the location that has no cow. Now we want to actually remove all of the state that depend on the no cow one as well. So let's see. While so where no cow is not empty, we would try to actually get the last one. Here's the last element. Okay, that is the state that has no cow. And whoever depend on this state, we should also who we actually remain on this one, we should also remove them. So we do no cow. We remove the last element, okay? But we already get it, and we will remove that one. And then we will see who would be depending on this state. So how can I know that who is depending on this state? So if the so-called after or this state decrease, it will equal 0. So actually, it's only the only guy who this one actually is the only guy who actually is depending on the current state. It actually only one element, then that guy need to be removed. Okay, it depending on the test state. Depending on this test state, this state is a test state. And then if there's a certain one that depending on this test state only, then the test state would be removed. So we should actually do no count. What's wrong it, okay? Okay, so we modify in this way that first we calculate the call to recording the shuffling network using the A array. And then this after would be the reverse array, would be counting the number of incoming state. So how many will come to this location? Okay, so here we have 0 go to 3, and then 1 go to 2, 2 go to 1, and 3 go to 3. Okay, so here we do have 1, 2, 3. So this one we actually say 1, 2, 3. We change it to count 0, count 1, count 2. Okay. So our state 0. Let's see. Let's redo it again. We have 0, 1, 2, 3 equal to 0, 1, 2, 3. It says 3, 1, 2, 3. So this one 3 go to we change it to 2. So this one 0, 1, 2. Okay, we minus 1 because the n is 1 to n. So we change it to 0 to n minus 1. So basically your call 0 will go to 2. 1 will go to 0. 2 will go to 1. And then your 3 will go to 2. So this one is an empty state. Okay, this one's an empty state. So here your counter end up to be 1, 1, 2, 2 coming to here. Okay. So this one is 0, 3 incoming to here. So this one after is counting how many will come to here. Okay. After is counting how many will come to here. Here 0 will come to here. Okay. Okay, and then we create a queue of no count. So we go into there to see if nobody actually will come to here. So nobody is depending on it. We will say this one. Currently, nobody. After here, nobody will come to here. We say there is no count. So this one no count. We decrease those no count one, and we also check if someone is no count and someone also depending on me to go into there. those state we would also decrease. So by doing this, we will get rid of those. We will get rid of those have no cow moving to, and also there may be a state, and it depending on a state that actually the state that actually has no cow. Both of those kind of the state we will remove them. Okay, and that's actually submitted. Okay, in pass. Okay. Okay, let me know if there is any question. Okay, see you next time. Bye bye.